In today's video, I'm going to attempt to build a DIY version of a retail product that's been getting a lot of online reviews lately. Now I'm going to use WLED, this will be completely local, and I'm going to attempt to at least match and maybe even exceed all the features of the retail version. So hang around. Hi and welcome to Resin Chem Tech. Now, odds are if you watch channels similar to mine, you've recently seen someone do a review on a new product that's out called Govee Curtain LED lights. Now, I don't own these, and from the reviews that I've watched, they look like a fine product, but one of the first videos I watched was one done by Chris Mayer, who does an excellent job of filming LEDs. You might want to check out his channel. But as I was watching this video, I thought, well, I think I can build a DIY version of this same thing. And by using WLED, everything will be local. And I think I can duplicate and maybe even add some additional features over the retail version. So that's what I set out to do. So just a little bit of a warning here. This video might be a little more scattered than some of my other videos. And that's because I was figuring this out as I went along and wasn't 100% sure how I was going to do some things. And I made some mistakes along the way, which you'll see. But like with most of my projects, there'll be a written guide of this entire process. Now, while I'll show some of the parts along the way, the written guide will have the complete parts list of everything that I used, along with wiring diagrams, step-by-step instructions, and more. You should also be aware that if you have sensitivity to bright flashing lights, there'll be a lot of that at the end when I show the final product. Okay, with all that out of the way, let's get started. So let's take a look at the LEDs we're going to be using for this project. If you take a look at this picture up here of the Govee lights, and then you look at these, they look identical. So this looks like it's the exact same type of light, at least very similar, but there is one major difference. One of the subscribers who actually ordered the Govee curtain lights was able to give me some information and told me that the spacing between LEDs on the Govee version was exactly 3 inches. If you look at these, the spacing between LED is 4 inches. So that is going to mean less LEDs in a given amount of space, so we'll see what kind of impact that has. But these particular LEDs are from BTF Lighting, and you'll notice the nice thing here is they are WS2812B, so they're the same chip that we're used to using for all of our other LED projects. And they do come at 100 LEDs per 5 meter length. So I'm actually going to be using 4 of these for a total of 400. And we'll see how much difference the 4-inch versus the 3-inch spacing really makes. But we ought to be able to control these just like we do any of our other LED projects. So I thought I would start out by filming my idea or my concept here. But the idea here is to take some black drain pipe. I've got a 5-foot length here. And I've actually cut this not quite in half, a little bit more than half. And the idea is that we will have one of these, the top and the bottom, that will add a little bit of weight to keep our strands straight, and will also give us a place to hide any wiring for power injection and the connection between our strips. Now, I opted to use this black drain pipe for a couple of reasons. One, it's much thinner and lighter than standard PVC, and which makes it easier to cut. And to be honest, I like the black color much better than something like this white PVC that I would probably have to try to sand and paint to get it to look decent. But the idea is if I have one of these at the top and one of these at the bottom, it's going to not only keep my strands somewhat straight, but the idea is hopefully I'll be able to roll this up and simply store this when it's not in use. So one of the challenges I'm facing that I've got to try and figure out is how do I want to slot or cut this PVC pipe so that I can insert my strands so that they're held securely and don't pop out, but also so I can easily remove them. So I thought about and considered a lot of different ways to cut these slots. And luckily I had a couple of scrap pieces that I could play around with, but I thought about, a router straight bit. I thought about trying to use a slot bit. I thought about a jigsaw. I thought about, a hacksaw. But the goal here is I want really narrow slots, just enough to hold the wires from the LEDs. So I don't want these very deep. I only want them cut on one side. After a little bit of trial and error, what I found worked best was one of these cutoff wheels on a Dremel. Now I did have to go out and buy the 1.5 inch because the 3/4 inch just simply didn't give me enough. I'd have to cut it at an angle for all those. This is going to be just enough to allow me to cut these slots, maybe 1/4 to a 1/2 inch deep. So with that, I'm ready to lay out all my marks. Since there was 4 inches between each LED pixel, by cutting slots about 3 inches apart, it allowed me to have 20 strands hanging down with about 1.5 inches left over on each end. Okay, the first pipe is cut, and at least conceptually, it looks like this is going to work fine. Again, these would be long strands of 20 LEDs each. And of course, when there's a little bit of weight on here pulling these down, it ought to pull them down tight. I might put a little dab of hot glue on these just to stop them from popping out but still be able to remove them. I'll see when I get to the stringing part. But I think that that's going to work, so now I just got to go ahead and cut the other pipe just like this one. Before I decided to actually string up the LEDs, I decided I might want to be able to test them as I went along. But to do that, I first had to build the controller. So I want to cover the parts we'll be using for the controller here. I'm going to be using an ESP32 in this case, not only because of better performance, but we do want the option to add sound reactivity here, and the sound reactive version of WLED is only supported on the ESP32. I'll be adding my normal logic level shifter that I recommend for all LED projects, but it's even more important here because we may want to keep that control box some distance away from the start of the LEDs, and the farther away you get the controller, the more likely you are to have problems with signal strength, which is going to cause flickering and misbehaving LEDs. So I highly recommend that you use a logic level shifter, especially for this project. I might try actually using this SN74 buffer gate shifter in this particular project. I did a video where I compared these two logic level shifters and really didn't see any performance difference. So either one will work, or even a sacrificial pixel will work. But just because I have some of these laying around, I might try using one of these for this particular project. Now, since we're also trying to match or exceed all the functionality of the Govee version, the Govee version has a push button on the controller, so we're going to add a push button here. But not only will we be able to turn the lights off and on, we will actually be able to change colors or effects with this button. As I mentioned, we're going to be adding a microphone for sound reactivity. This is a different microphone than I normally use. I'll talk about that in just a minute. I have a 5-volt, 15-amp power supply that will be running everything. And I'm going to add, just for the heck of it, an IR receiver. Now, you can control WLED through a web browser, through Home Assistant, or via the mobile app on your phone. But we're going to add this receiver so we can actually have a standalone remote that we can use to control the lights as well. And of course, we'll have various wiring connectors that we'll use, and you'll see some of those as we go along. And of course, the blog will have the complete parts list of everything that I use. And we're going to mount all this, as we always do, on the Electro Cookie prototype board. However, in this particular case, I am going to mount my ESP32 on these pin headers. That's going to allow me to easily swap out the ESP32 between the sound reactive and the non-sound reactive version. And the reason I want to do that is because the sound reactive version normally lags a little bit behind the official release. So the official WLED might have some new features or some new matrix effects, and I want to be able to easily swap this in and out. I can also do that in this particular case because, in deference to so many of you out there who've told me you don't have a 3D printer, we're going to do this entire project without using any 3D printed parts. Instead, I'm actually going to use this. It's just a simple plastic box, and I'm going to put the power supply and the controller, all the connections inside of this box. And the nice thing about it is it does provide a little bit of weather protection. It's not like it's IP67 rated or anything, but if you actually have this outdoors and get a little bit of light rain, it's at least going to give you some protection. Another nice thing about this particular box is that I want mine to be portable. I want to be able to take it down and store it. So if I have any additional mounting components or things like the remote, I can actually put that in here and keep all that together. So we'll modify this as an example of things that you can do instead of using 3D printed enclosures. I did briefly want to talk about this microphone, as I've not used that before. In all my previous WLED sound reactive projects, I've always used the Max 9814. This is an analog microphone, while this one is digital, and this is the INMP441. It actually is the one that's recommended by the Sound-Reactive WLED website, and being digital, it's supposed to give much better performance than the analog version. Like all my projects, I like to run a breadboard test before I create a final soldered version. So this is wired exactly the same with all the components here that will be on the final Electro Cookie version. I went ahead and I flashed the latest sound reactive version of WLED onto my ESP32. That way we can test the microphone. I've added the IR receiver for the remote control, and I've added the push button as well. Oh, and the microphone is here, but you can't quite see it. Can't quite see it off the screen here. You'll see that when I pull back in a minute. Right now, I'm just using one strand of 100 LEDs over here, and that will be enough just to let us know that the functionality is working. So let me pull back the camera or switch cameras here, and we'll plug this in, and hopefully everything will be working. I just wanted to break in here quickly and mention the installation of WLED. I'm not going to go into it in detail here. I cover it in other videos, and it's covered a lot of other places, and there are step-by-step instructions on the official WLED website. Check the video description. You really just plug your ESP32 into the computer, drop down the box, and select which version you want to install. I'm going to be installing the Sound-Reactive version on one ESP32 and the latest version of the standard WLED on another controller. Again, I'm not going to cover WLED in a lot of details in this video. I'll show a few important points, but otherwise, check out the official WLED documentation for more information. Okay, this might be a little bit better angle. Here's my power supply, and I'll go over all the wiring in a bit more detail later, but just know that I am splitting off 5 volts to run to my controller and a separate 5 volts over here to the LEDs. So I haven't configured anything in WLED yet. So if this works, we ought to see the first 30 pixels light up in orange. So we'll cross our fingers, plug this in, make sure our power supply is on, and fail. We've got nothing. All right, well, I didn't see any magic blue smoke, but I definitely smelt something, and this ESP32 got really hot really fast, so something is wrong here. I've got some kind of big fail, so I've got to drop back and reevaluate. Well, it didn't take me longer to discover the problem. Turns out I had reversed my polarity here on the positive and the ground on my ESP32, and it doesn't like that. And even after I corrected it, this is not coming back on, so I've fried this board. Just let that be a little bit of a lesson. I know a lot of times people are scared, and yep, I screwed up, I messed up, it happens all the time. And so I'm out a $3 or $4 ESP32, and I'll just have to solder the headers onto another one, reflash WLED, and start over again. But it's not the end of the world. Okay, I lost about 15 minutes to put new pin headers on a new ESP32 and reflash WLED. And I've also double checked to make sure that all my connections are correct this time. So we're going to plug this back in. We'll change back to the cameras, try this again. Hopefully no other components got damaged by that, but I think it was probably just the ESP32. Okay, we're going to try this again. I will admit being a little bit more nervous the second time than I was the first time. Plug this back in again, and hopefully, yeah, our light came on. That's a good sign. But we still don't have any LEDs lighting up. Ooh, luckily it was just the GPIO pin setting in WLED. It was defaulting to the wrong GPIO pin. So I just had to go in and tell it the right GPIO pin. So that's the good news. We've got our 30 LEDs lighting up in orange, which is right. Now I'm going to go into WLED, and I'll show this later. I'm going to go ahead and tell it I've got 100 LEDs. I'm going to set up the microphone and the IR and the button GPIO pins so we can come back and test all that. All right, I've went in and I've configured all the GPIO pins in WLED. Now I've got all 100 lit up here. So one of the first things I want to do here is I'm going to go over and just select a Sound-Reactive. And you can see already that it's reacting to my speech. So the microphone is working. So all the different Sound-Reactive effects, we'll come back and look at these later when we get them hung up. But that does let me know that the microphone is working. So I'm going to go back to solid, and we will test, and our button is working. So that's good. Now we will try remote, and I can see my remote is flashing up here, but it's receiving on this, and I know I can fix that later. So a quick follow-up on the IR remote. I did go ahead and decide to flash standard WLED, the non-Sound-Reactive version, to a second ESP. And I swapped that out into there. And if we take a look at this, again, our button works. But in this particular case, the IR remote also works. So come to find out that Sound-Reactive WLED has IR functionality disabled by default. Apparently it causes some issue with the sound reactivity. So you can enable it, but it does require that you modify a header file and compile your own. But for the purpose of this, I'm going to stick with standard Sound-Reactive. It's just note that when you are using Sound-Reactive WLED, currently you cannot use an IR remote. I'd like to give a quick update here on the soldered version as I work on it. I'm not going to go through step by step on this because it's really just a standard WLED controller with some optional components. and I do cover that in other videos. Now, I did opt to go ahead and use the SN74 shifter here, really just because I had some extras laying around from my other project, but you just as easily use the I2C shifter, and the blog article shows wiring diagrams for both types of shifters. And of course, this is socketed, and the nice thing about that, it does allow me to do some wiring underneath. It also allows me to swap back and forth between the standard WLED and the Sound-Reactive WLED for testing of the curtain. So here are my thoughts on the controller box. I've just got a plastic storage container here with a lid that clamps on, enough room for my power supply and my controller board. I think I'm going to mount the controller board on these little offsets. The bottom of this is concave enough that I don't think the end of these will protrude and stop this from sitting flat. Plenty of room to make my power connections in here. I've gone ahead and added offsets. I've gone ahead and used a Dremel and a box knife to cut a hole for my AC power supply, a drill for my hole for my push button. Right now I have this small little hole for the microphone. Again, I'm not 100% sure on the placement of that. I'm going to have to do a little bit of testing. So this is with the electro cookie board mounted and my power supply, and my push button is mounted. Again, I still haven't mounted the microphone because I'm not 100% sure on that. But I'm far enough along, I think I want to go ahead and hook up some temporary power connections and do one final bench test of this controller before I move on to connecting it to the full install. Okay, I've made temporary power connections here just to give this soldered board a quick bench test. Currently, I have standard WLED. There we go. That is a good sign. So let's go ahead and bring up WLED. Okay, just do a quick check of our colors, make sure that those are correct. Just do a quick, everything looks good there. Let's go back to solid, test our push button. That works. And we will test our remote. And that is working. So everything is good with the standard controller. I'm now going to swap out the standard controller for the Sound-Reactive version. Okay, I've swapped out the controller. This is the Sound-Reactive version. Let's go ahead and fire that up. Once again, we'll check a couple of colors. And of course, we do need to check the microphone. 1, 2, 3. Okay, so the microphone is working. We'll double check the button. It turns them off, turns them back on. So all is good. Now, of course, the IR remote does not work with the Sound-Reactive version. But otherwise, I can either use the Sound-Reactive version or the standard version. Everything is good with the controller. With the final controller built and tested, it's now time to move on to trying to string those LEDs and hanging our curtain on the wall. So this is how I'm going to attempt to do this. I'm going to try it here on the floor and hopefully this will work, but this is going to be pixel 1. So this is where it's going to connect to the controller, and then it's just going to be serpentine back and forth. I'm actually going to use a little bit of masking tape just here at the start to hold everything in place. Once I get everything adjusted, I'll probably add a little bit of hot glue. So we're going to start here with pixel 1. I'm just going to stick that. Okay, we're at the end of the first strip here, and so far so good. Now, what I'm going to do is just use the JST connectors here to connect my second strip. Now, unlike normal WS2812B pixel strips, there is no copper pads to be able to cut this. These are very thin wires. It might be possible to cut these and solder them, but I'm going to use the JST connectors because we're just going to be able to hide those inside of the pipe and you won't see them. But before I actually do that, I'm going to go ahead and connect these up, and I want to do a sanity check just to make sure that we don't have any issues with wiring or even a faulty LED strip. Okay, while my controller box isn't done yet, it's far enough along I can make some temporary connections. So I've gone ahead and I've connected that up. I've went into WLED and I've told it that I now have 200 LEDs instead of 100. So let's go ahead and turn that on. All right, well, you can see that all of them are lighting up. The ones at the end are flickering and acting funny, but you can also see after right about 100 LEDs, the color is starting to fade. Maybe you can't see it from the orange towards the red. So that's most likely a power injection issue. We are going to do power injection at the end of this second strip, so hopefully that will take care of the problem, but everything up to this point is at least working. Okay, I've completed the second strand, which is a total of 200 pixels, but at this point I'm actually going to do power injection. So I'm running a separate 5-volt line down here to inject power, but I want to go ahead and test this strip that was showing as faulty before, now that we actually have the power injection. Need to up my WLED count to 300 pixels now to count for that third strand. And if we turn that on, well, they appear to be fine. Okay, all 4 strands, a total of 400 pixels, have been strung up there. I've went ahead and updated WLED to say I've got 400 pixels, and we turn it on and everything looks good. I couldn't help myself. I went ahead and defined the matrix layout, but I at least wanted to see at least a few matrix effects to see how it was going to look, and it's actually looking quite well. So now the next test will be to try to raise this up and adjust everything so that the strands are all straight and aligned. And I did want to mention, it appears that that strand that was acting bad before does appear to be working fine, although I did put it at the very end. That way, in case I get to the point where I do need to replace it and it does start to act up, it will be easier to do than if it was somewhere in the middle. But let's take a quick look at the power injection while we can still see the back side of these pipes before it gets hung up on the wall. So for power injection, I'm just running a separate set of leads from the power supply. I'm using a barrel connector here. You can see I'm running that down through my pipe, and then right there I'm actually using Wago clips to connect to the power injection. And again, I go ahead and continue that wire down to do power injection at the end. Now, an interesting thing about these fairy lights is they only have power injection wires at the beginning of the strip and not at the end as well, like WS2812B. So I just used another JST connector, cut off the data line, and used that for my power injection. Power injection is necessary because of the voltage drop, and we saw what can happen when the voltage drops too low. So I went ahead and decided to remove the masking tape that was holding the LEDs in place. I just felt like as soon as I tried to pick this up, that masking tape wasn't going to hold the LEDs and they were going to pop out of those slots. So I added really just a touch of hot glue over the top of each slot, just enough to hold the LEDs in place. And the idea is, when I'm ready to store this, I would simply roll it up to the 2 halves, put them together, maybe bind them together with a rubber band or a zip tie, and then I could store them and take it back out whenever needed. Now, why am I talking about the storage now before I ever even get the project done? Well, that's because Mrs. Resin Chem saw me running these here on the floor, and she actually made the recommendation to install them right here. And she said, why would you even want to take them down? I think I've already got a pretty good wife approval factor on this particular project, and I may not be taking this down and storing it when I'm done. We may actually leave it right here on the wall. But for now, I need to go get her and have her help me hang them up. Now, what I didn't show earlier is I actually mounted a couple of eye bolts into that top piece. This whole thing is very lightweight, so I used about a 2.5-inch nail directly into the drywall with no anchors to be able to hang this up, and it is holding it securely, so not a lot of concern. Now, I actually had someone in one of my comments tell me I needed to smile more. Well, get ready for it. I was pretty happy that this worked out. This is the final design I came up with for my enclosure or my controller box. I've been able to do all of my wiring. Again, I won't cover all that. It is covered in the wiring diagrams in the blog article. Now, instead of trying to determine the length of these wires and having them dangling out, what I decided to do instead was keep these very short and then just build myself some extension cables or pigtails. So there's one for the start of the LEDs. I've got another one for my power injection line. And again, I just used some braided sleeve and shrink wrap to try to make these look a little bit neater. Now, the nice thing is, when it comes time to store this, I can simply unplug the AC cord from the outside. I can pull these back. I can take my extension cables, I can take my remote control, I can take my extra controller, put those all in there, put the lid on, and now I've got an easy way to store this until the next time I want to use the LED curtain. So with everything built, it's time to take a look at the final project. Now, just be aware it's very difficult to film LEDs with the camera. And so what you're going to see here on the screen does not do it justice to how well it really looks. This is also the part to be aware that there'll be a lot of strobing and flashing lights if you happen to be sensitive to that. So let's start out by taking a look at some of the features and effects of standard WLED. We're going to start out with a fun little animation here. We're only going to take a look at a few here. There are currently over 40 different specific matrix animations, and I'm sure that more are going to be added all the time. So this is just a handful. And note that each of these animations have additional adjustments to them, not just brightness, but things like speed and intensity. So there are a lot of different settings for each of these that you can fine tune these in. I kind of like that one. It almost looks 3D. It's very hard to film pixels or LEDs. So this looks much, much better in person than it does here on the camera. But it'll give you an idea of just a handful of effects. I'll show more of these effects towards the end when we're actually going to do a comparison to see how we did versus the retail version. But there are a few other features that I do want to point out here. And one of those is the ability to do scrolling text. Change the color on that. There's another unique option here, and that is the ability to actually upload images to WLED, and we'll take a look at that next. Now, one of the things that the Govee and I believe a couple of other versions have is the ability of what they call DIY mode, where you can draw with your finger or possibly even upload an image to the curtain. Unbeknownst to me, this was also available in WLED. It just involves downloading a simple HTML file. You come into here and you give it the IP address of your WLED controller. You tell it the scale. So in my case, it's 20 pixels by 20 pixels. And now I can simply click and upload any kind of pixel art. So we'll just choose an angry bird here at first. And you see it actually gives me this, and it looks like this on the matrix. Now, it's not high resolution. We're only talking 400 pixel resolution here, but you can definitely tell what it is. Also note that not only does it do that, it'll actually create the Home Assistant YAML for you if you want to use this in an automation. Let's just try another one here. Let's try this alligator. And we'll just come down here and tell it to send a device. And there you can see it kind of looks like the alligator. Or what's even more fun is I'm actually going to take this, which is actually a photo, and I'm going to go ahead and tell it to send to the device. And that's what that looks like. No, it's not photorealistic, but if you have the ability to create your own images in a pixel art format, you can simply upload them directly to your matrix here. It's kind of a nice feature I didn't know was even available in WLED. Okay, now let's take a look at the Sound-Reactive version. The only thing I've done here is I've swapped out the ESP32 with standard WLED for the ESP32 with Sound-Reactive WLED. And before you make any comments, I apologize about the music I'm using here. I would love to be able to show you what it looks like with something like AC/DC or some music that you might recognize, but copyright prevents me from doing so. And just to give you an idea of how good the microphone is here, I am standing approximately 15 feet away from the microphone. I'm using a mic for the cell phone here, but my voice is not being amplified whatsoever. I'm going to actually walk all the way around my basement here and continue to talk. Again, my voice is not being amplified. This is just how well that microphone is actually picking up the sound. So I'm probably a good 30 feet away at this point. And I'm going to walk back over closer, and you'll see how as I get closer, it picks up more of my voice and kind of expands all the different lights. So the microphone is working really well. Let's take a look at a demo now with some music. So let's take a quick look at the feature comparison between the Govee version and the DIY version. Now, I don't own the Govee lights, so the information I provide here is based on other reviews and the official Govee website. When we take a look at the outdoor rating, both the Govee LEDs and the LEDs I used here are IP65 rated. Now, the controller for Govee is only IP44 rated, which means it's protected against a little bit of splashing, which is probably the same thing you get out of that plastic box that I used for my controller. As far as Alexa and Google, Govee does support that. WLED currently has some Alexa integration. To be able to use Google, you would have to use something like Home Assistant or some other intermediate party. Local control, most of that is available through the Govee app using Bluetooth on your phone. For WLED, all control is local. As far as the app type, again, for the Govee, you have to use your phone to be able to control the LEDs. For WLED, you can use an app on your phone, you can use a browser, and of course you can use Home Assistant. Speaking of Home Assistant, currently the Govee integration into Home Assistant does require use of the cloud, while WLED is completely local with native integration into Home Assistant. Animation, I really don't know how many Govee has. I'm going to say it probably has dozens of different animations, but WLED has well north of 100 different animations, 40 plus animations specifically made for a matrix like this. As far as scenes and presets, yes, they both have that. WLED has the ability to create presets and playlists, and you can set themes based on colors and other options. Both have sound reactivity, both have an integrated mic. The Govee version has that. Apparently you can finger paint onto your phone screen and upload that as an image. WLED currently doesn't have that, but it does have the ability to upload an image, which we saw a little bit ago. Now that's supposedly pending with the Govee version, but I don't know if it's currently there as of the time of this recording. The Govee version has a local button, but is on-off only. WLED has a multi-function button. WLED has the ability to use an IR remote with the non-sound reactive version. Govee does not have an IR remote. Now Govee does have more LEDs. Their current curtain has 520. What I built only has 400. You could easily add more LEDs to my version. You just need a little bit bigger power supply and probably a longer pipe. But the ESP32 could easily support 800 to 1,000 LEDs. And finally, the cost. The Govee version is currently going for about $130 on Amazon. It's hard for me to say exactly what you would spend to build the WLED version. It kind of depends on what you might already have at home, but you're not going to save a lot of money. I spent about $70 for the LEDs, about another $20 for the power supply, $15 for the pipe. I probably have around $130 into mine, and you're probably going to have somewhere between $100 and $150. So this particular project wasn't about saving money, but it was really about being able to build a local, completely within your control version with what I think are more features than you get out of the retail version. Plus, for me personally, I got the enjoyment and satisfaction out of building my own instead of just buying a retail version. So that's going to do it for what is, once again, a rather lengthy video. And I wasn't even able to cover everything. So if you are interested in building one of these, be sure to check out the related written version of this, which you can find a link to down in the video description. It will contain all the information that I just wasn't able to cover in this video. You'll also find additional information down in the video description, including links for more information. If you found anything in this video useful, do me a favor and hit that thumbs up button. Click that subscribe button if you'd like to see more of my content, and ding that little bell icon if you want to be notified when I release new videos. As always, I would like to say thank you for watching, and I hope to see you soon.